Hey, so what did you think of that intro? Pretty cool, right? But yes, you did read the title correctly. I have made a keylogger. No, hold your applause. For those of you who are uninformed, a keylogger is a program that records every keystroke made by a user, usually with the intention of stealing sensitive information, like passwords. Now, before we get into the why and the how, we need to address something first. These visuals are trash. It's just subtitles in a white background. Fear not, that's where our special guest comes in. Say hello to Jira. Okay, now Jira, say hi. See? Look at her go. Jira is going to be assisting me with the videos so that the visuals are a little more interesting than just some subtitles on screen. Hopefully. I don't know, she kinda sucks. Okay, I'm sorry. You know I didn't mean that. Now that you've been introduced to Jira, let's get into the first question. Why did I make this? And to put it simply, I just wanted to see if I could. I first got the idea when I was working on a different project. I probably should have made a video on that first, but oh well. This project involved needing to monitor keystrokes while the program runs in the background. And that's when I had an epiphany. Wait, couldn't I just make a keylogger? When it comes to answering the second question, how did I make this? That one is gonna take a little longer to explain. AKA the rest of the video. I am very much a novice when it comes to creating malware, with this being my first ever attempt at something like this. Even then, the average computer is likely vulnerable to this program, so I won't just be talking about how awesome and cool this is, even though it is really awesome and cool. I'll also be touching on how you can protect yourself against something like this. The other project I mentioned earlier was made using Python, so I figured I should use Python for this one too. No, Jira, not that type of Python, the programming language. Where did you even get that from? Whatever. Okay, so that's cool and all, but how do we monitor keystrokes? Well, we're just gonna use the same library that I used for my other project, PyInput. Jira, can you go get the code ready? Alright, thanks. So let's go through my first iteration of this keylogger. Skipping past the functions for a second, this is the listener. This basically just says that when a key is pressed, it will trigger the onPress function, and that when a key is released, it will trigger the onRelease function. Pretty simple, right? Now let's look at the first function, onPress. The first thing it does is a simple try except block. The reason we need this is because keys like backspace have the name attribute, but not the char attribute, whereas it's opposite for something like the A key, which has a char attribute, but not a name attribute. For our needs, these two serve the same purpose, that being a name we can associate with a key. So this try except block just simply gets a name for whatever key was pressed. This next line creates the string that will be saved to our output file. And this final portion of the function is what actually logs the keystrokes. First, we set the file path where we want it to be saved. I chose to save it to the local user directory under an extensionless file named Steam because, be honest, if you were going through your files and saw that, you'd be like, yep, sounds about right, and go on about your day. Then, this next portion checks to see if the output file already exists. If it doesn't, then we'll make a new file from scratch and write to that. If it does, then we'll open the existing file and append the string to the end. And that's pretty much it for the first iteration. The onRelease function is almost the exact same as the onPress function, with the only difference being that the string it creates says released instead of pressed. And boom, we did it. We made a keylogger. Here's what the output file would look like. Wait, what is that? Jira, zoom in. What is that? So, it turns out that hotkeys like Control-C register differently than how you would expect them to. So, instead of your output looking like this, it ends up looking like this. As much as I'd love to tell you that this was an easy fix, yeah, it was not. I scoured the internet for hours trying to find a library that would fix this for me, but in the end, I just had to do it myself. So I went through, manually inputting every possible hotkey I could, then taking note of its recorded output so I could swap it with the correct one. That ultimately resulted in this monstrosity of a function. Just a giant collection of try except and if else blocks. Is there a better way to do this? I would sure hope so, but I couldn't find anything. Okay, problem solved. The output file looks how it should, so that means we now have a fully functional keylogger. But wait, if this program was installed on another person's device, how would we get the logs? Simple, we can just use a Discord webhook. Now, you may be asking yourself, what is a webhook? Well, to put it simply, it's a method of notifying one system through an event triggered by another. Using a Discord webhook specifically allows for this notifying to be in the form of a message. It's kind of like a Discord bot, except this is one-way instead of two-way. Okay, sweet, so we can use that to send the logs, but how does the program know when to send them? There's multiple ways I could have gone about this, such as having them send every day at a certain time, or having them send every time the computer starts up. I chose to set it up to where it sends the logs whenever the output file reaches 300 or more entries. Now let's look at the code. First, let's stop by the onRelease function. It looks a little different from the last time I showed it, but this is mainly because the function can now act differently if the output file is empty. More on that in a minute. What we want to focus on are these two lines. The first line gets the number of entries in the output file, and the second line passes that number to a function. This function it's passing to is the function that sends over the logs. First, it does a simple if statement to see if the number of entries is greater than or equal to 300. If it's not, then the logs won't be sent yet. But if it is, then the function will create the message, clear the output file, then execute the webhook to send over the logs. Now before you ask, the reason we empty the output file is because otherwise the file would stay over 300 entries, constantly executing the webhook. Here's an example of how the webhook output could look. Not much to touch on other than the name here is the same as the name of the user who the file is coming from. This way you can differentiate between multiple users. While we're at it adding new features, let's also implement a simple kill switch. The way it works is if it detects an extensionless file named kill in the local user directory, it stops the program. Not much to it. So now we have a fully functional keylogger. Let's just bundle it into an exe file and load it onto another computer, and it's flagged as a Trojan. I'm not sure what I expected. I mean, this quite literally is malware, so I guess it's good that Windows Defender would have blocked it, but now we've reached a roadblock. I'm sure there's some super hacker stuff I could do to trick Windows into letting it through, but as I said earlier, I'm just a novice. I don't know what I'm doing, so I guess that's it. I made working malware just to be stopped right before the goalpost, with no idea how to work around it. Or that's what I would be saying if I hadn't ordered the solution a week prior for completely unrelated reasons. I present to you the rubber ducky. No, Jira. Well, I did say rubber ducky. I should have specified. Okay, take two. Now, I present to you the USB rubber ducky. What is a USB rubber ducky, you ask? You sure do ask a lot of questions. But anyways, the USB rubber ducky is a keystroke injection tool. To humans, it presents itself as an innocent flash drive, but to computers, it presents itself as a keyboard. There's more to it than that. You can read about it on Hack5's website, but for this video, all you need to know is that we can use it to type stuff really fast. This may sound underwhelming, but trust me, it opens a whole new world of possibilities. So we have the rubber ducky, but how do we use it? Well, we just do what I do anytime I'm trying to learn something new, and look at examples. As I was looking through the official payload repository, I came across the perfect payload for my needs. I mean literally, it's called the perfect stealthy payload. Let's run through what it does. My rundown on this is going to be brief, as I end up making my own changes to it later. These first three lines just define where the script downloads the program from. This whole chunk determines if the computer is on Windows or not. And now, we're actually doing stuff. First, we open PowerShell as an administrator and create a new folder hidden in the Windows directory. We then run a command that adds that folder to the exclusions list, meaning Windows Defender will ignore any files in it. Then, we download our program and start it right after. Afterwards, we run a command to add our file to system startup. That way, every time the computer starts, so does the program. And finally, we just exit out of PowerShell. This sounds amazing, right? But to use it, we're gonna have to make some changes to the script and to our code. This script needs to download the file from somewhere on the internet, so that means I would have to upload it online. Only problem is, then I'd have to upload my webhook URL for anyone to see, which you never want to do. So here's my solution. Instead of having our log file and kill switch in the user directory, let's move it into a subfolder called source. While we're at it, let's change the log file's name from Steam to main, because why not? In this folder, we'll create a new extensionless file named src. The first line of this file will be our webhook URL, and the second line will be the number of entries required to execute the webhook. Along with those changes, we've added this section to the code. This section is responsible for loading the src file and making sure it can connect to the webhook. If it can connect to the webhook, you'll get a message like this. If it can't connect, then the program won't run. So problem solved. I can now upload the program without having to upload my webhook URL. Now we just have to make some changes to the script. These first two lines are where we define our webhook URL and number of entries. Everything else is basically the same until we get to this line where it pulls the file from my GitHub repository. This next part is where we create our src file and set its contents. From there, it's the same as before, starting the program and adding it to startup. So now, let's see it in action. And okay, go for it, Jira. I got you up on the big screen. That is taking forever to download. Yeah, that's gonna be a problem. While the script does work, it takes way too long to download, so you definitely get caught while trying to sneak this onto someone's computer. Unless we redo a bunch of stuff, there's no real way we can make the download go faster. So if we can't make it faster, then let's just hide it while it's downloading. The way we can achieve this is by using a PS1 file, which is just a file extension for PowerShell scripts. Here's how this new version works. Instead of opening PowerShell, the script opens command prompt. From there, it creates and sets our src file in the source folder. Then, it downloads a PowerShell script from my GitHub repository, saving it to the source folder. After it finishes downloading it, it will run the script in a hidden window so nobody will notice it. This PowerShell script does all the heavy lifting that the old version did. It creates the directory, adds it to the exclusion list, downloads the file, starts the file, and adds it to startup. Once the script is finished, it will delete itself. So now, let's try this again. Jira, you're up. How is it still slow? Okay, so it turns out that even the script to download the file takes too long to download. So what now? At this point, why don't we just make it from scratch? I mean, it'd probably be faster than downloading it. No, seriously, that's what we're gonna do. Not the whole program itself, just the PowerShell script. So once again, here's how this new version works. The script opens PowerShell as administrator and runs a command to change the execution policy. We do this to ensure that our PowerShell script will be allowed to run. After that, it exits PowerShell, then opening command prompt as administrator. Same as before, the first command we run is to create and set our src file in the source folder. Then, we run this long command which creates the same PowerShell script but from scratch. And finally, the same as before, we run the script, then exit out of command prompt. Hopefully, for the final time, let's try this again. Jira? Yeah, you already know. And boom, look at that. We can now finally say we have a fully functional keylogger. I know, it took us long enough. But just because we've got it working doesn't mean we're done with it. Let's add some new features. But this video is long enough already, so we're gonna speed through them. Remember this? Boom, now it has color. The color is based off of the name of the user who is running the program, so different users get different colors. How does it work? I don't remember. Remember the kill switch? Well, now it notifies you when it's activated. And look at that, it also has color. Wait, does that say mouse kill switch? We're not logging the mouse. Well, guess what? Now we are. Oh yeah, look at those logs. Oh, what's that? Not only does it log left, middle, and right clicking, but it also logs additional mouse buttons like mouse 4 and 5. Yeah, you know it. Wow, so we're logging the keyboard and the mouse? What else could we possibly log? I'll tell you what, the clipboard. You wanna copy something? Well, guess what? I do too, and I'm copying it straight to the logs. That's pretty much it for the program itself. So how would you protect yourself against this? You don't. Nah, I'm kidding. There's multiple steps you can take to prevent an attack like this. The easiest way to stop this is by limiting access to the run command, PowerShell, and the command prompt. The Microsoft Management Console is your best friend for this. Now, what do you do if you think it's already on your computer? Well, if it is, hopefully it's my version so you can just activate the kill switch. Either way, the first thing you should check is the Startup tab in Task Manager. If there's anything there you don't recognize, you probably want to disable it. There's also the option that probably first comes to mind of running a virus scan, but I'm not sure that's going to work as well as you think it would. We already know that Windows Defender won't detect it because we added it to the exclusion list, but what about another software like Malwarebytes? Well, I ran a scan and Malwarebytes didn't detect it either, so I'm not sure if that's the way to go. Keep in mind, this is my first time ever making malware, and there's certainly more advanced malware out there that can fly under the radar much better, so be cautious. But with all that out of the way, that's it for the video. The link to this project will be in the description if you want to mess around with it for yourself. All I ask is that you please don't do anything illegal with it. A big thanks to my girlfriend Salami for helping me with the visuals. I couldn't have done it without her help. This is my first time making a high effort video like this, so if you liked it, please let me know, whether that's through a comment, liking, subscribing, or all of the above. Whether positive or negative, I'd love to hear your feedback. I hope you liked Jira, but now it's time for her to wave you all goodbye. Thanks for watching.